Hi, good evening. Today we'll see about a few tips to construct diagrams, especially when you're analyzing graphs and scale diagrams, etc. Now, why I'm giving this just before exams is like for you to just give it a thought while you're constructing these. If you're using this, you might be able to save some time, which you can use it for other calculations and so on. All right. And I also want to stress on non-uniform graphs. There is another video where I've discussed about how to interpret graphs, do calculations in detail, but here I'm just stressing on only non-uniform graphs, how to analyze them, and also how to quickly construct scale diagrams and so on. All right. Now, what do you mean by non-uniform graphs? When you have the value constantly changing on the x and y axis. Say if you take distance time graph, and if with respect to time, if you see the displacement or the distance constantly changing, you're not going to get a straight line. Instead you might get a curved graph. Right? Now, how do you describe this? The tip I have told you before is look for the quantity that is on the y-axis and on the x-axis and divide and check what is the gradient that will be equal to, which means here d over t will be your gradient, right? Now, as per the theory, what is distance over time? It is velocity or speed. So gradient will represent velocity. So how is the gradient changing here? It is decreasing. If you look at it, you will notice here it is steeper, and then as you go, it becomes more and more gentle or inclined, right? So you have a steeper gradient here, a less steeper gradient here. So you see that it is going, or the velocity is decreasing. So you don't have the gradient to be constant. Now, such graphs, is analyzing part or interpreting is easy. But if they ask you, for example, at t is equal to say 5 seconds, what is its velocity? How would you calculate? I'm stressing on this. I know for a fact that many of you might be thinking at 5 seconds, immediately you would drop a line here. Take this value, say if this is 20, you would divide displacement or distance over time, 20 upon 5, which is equal to 4 meters per seconds. I do not know how many of you will be shocked to know that this calculation is wrong. It is incorrect. Why? Because as you see, it keeps on decreasing. It's not a constant gradient graph. Okay. The gradient represents velocity in a distance time graph, right? Hence, you have to find the gradient of the particular time. At that point, you must find the gradient. So how do you do that? So if this is wrong, then what is this velocity? Because usually if it was a straight line, if you had a straight line, this calculation would be correct because the gradient would be the same, because y2 minus y1 will give me the same 20 minus 0, and x2 minus x1 will be 5. So this calculation would be correct because it is having a constant velocity. So at any point in time when you are calculating the gradient, even if you take two values from x and y, you will get the same answer. But if it is a curve, I repeat, if it is a curve, if you want to find the particular velocity at that point in time, then if you do this calculation, it's wrong. Then what is this? This is actually, this value gives you the average velocity. The total distance covered in that particular time, 5 seconds, is 20 over 5. This gives you, it gives you the average velocity. Now, there is a difference between average and instantaneous velocity. Instantaneous mean at that particular time, what is the actual speed or velocity of the object? How do we find out? You have to draw a tangent to this point because that's what gives you the gradient at that point. So you first have to construct a tangent, and the gradient of the tangent will be the instantaneous velocity. So this is just average velocity, which gives you a rough estimate of the entire journey up till that 5 seconds. So how do I proceed to find instantaneous velocity? velocity or actual velocity, that should be equal to gradient. Now how do I find the gradient? Now your math teachers may have taught you, different methods to construct the gradient accurately. My math teacher has given this tip for me. I don't know if you know it. Yes, you can follow that. Or for those of you who do not know, you place a ruler, all right, here. I'll get a ruler. All right. So when you place a scale or a ruler, sorry, the power is on. If you watch carefully, see, I can place the ruler like this, or I can tilt it like this, or I can place at this position. See, at different points you can see, you might be confused which is the correct one to construct the tangent accurately. I would advise, or as I said, my teacher taught me this, when you are placing this, when it is touching, you look at the gap between the ruler and the curve. All right, see, as it goes away, so say at the same distance from your, more or less this much, if you take here, you should have the same gap here as well. See, if I place it tilted a little bit, you can see at the same distance, this is much longer than this gap. I don't want you to waste time there, but by roughly looking at it, you will get an idea. If I place this, definitely is going wrong because this is, the gap here is greater and here it is lesser. So try to position it in such a way that you're getting more or less or closer to an accurate value, right? So you construct that line, so it touches at that particular point, and then find the gradient of this tangent that you have drawn. So this will be your y2, this is your y1, this is x2, this is x1. So you all know the formula. So you get y2 minus y1 upon x2 minus x1 gives you the actual velocity at that point in time. All right. So if you get a curved graph to analyze, please remember this point. Don't straight away do the calculations. You have to calculate grade. So now this is for distance time. What about velocity time graph? If they give you, if it is a curved graph, what does that represent? We'll see that.